Assalamu alaikum, everybody. This is the original Scary Ammi, and I'm here with Kim Langen for our sorry, for our regular Thursday evening session where Kim joins us from Canada and I join in from Pakistan, and we use Kim's expertise as a global educator and as an extremely well-known math expert. We use her expertise and we try and pick her brains, and basically the aim of these are to just help mothers become better teachers, because especially with COVID-19 our homes have become schools, and mothers have become teachers, fathers have become coaches, roles have been all mixed up, and since mothers don't undergo any kind of academic teacher training, these sessions are linked towards helping mothers become better at teaching their children. So, since Kim's expertise is math and she is the CEO of Spirit of Math, we've been doing a lot of sessions on how do we teach our children better math. So today's topic has been recommended by Kim herself, which is called Problem Solving for Younger Grades. And those of you who are watching, I wanted to tell you, so I registered my children for the Spirit of Math contest. And because of that, we've been checking out the Spirit of Math practice website. And I think it is such a great resource if anybody wants to use it. I think it was really cheap. Maybe it was $10 for the month. I've forgotten. But it has these videos, and Kim really goes into detail. So I've seen a lot of the Khan Academy videos, but they're not so detailed. And then I really liked the questions, both the practice questions and the test questions, really good. And registering for the contest is really cheap. It's 700 rupees, and they have added a Pakistan bank account, so it was really simple to do. So I would strongly recommend that everybody kind of try and do it. So Kim, why did you want us to discuss problem solving?
Well, I think a lot of what people think of for problem solving, especially for younger children, is often not really problem solving. And we're going to talk a bit about that. But for the kids of the future, they have to be able to solve problems, bottom line. And it's and in order to solve the problems, yes, you have to have some skills to use. But if you just have skills, you know how to add and subtract or multiply, divide, you know how to do algebra, and you just know how to, it doesn't mean you can problem solve. It doesn't mean that you can actually use that in the problem solving. And so often we think about, well, we've got the math over here and then we've got the problem solving over here. You need to combine them. And also this problem solving gives you the reasoning and the logic that you require, that your kids, our world's kids will need for the future. And I think this is so critical because the problems that they're going to face are things, and I've been saying this for years, are problems that we would never have even imagined. I mean, just even think about COVID. And if we're able to teach them, mathematics is a brilliant place to teach the problem solving, because you can see right away whether you've got the right answer, so you understand whether you use the right logic. And for our children of the future, we need to. It's not just an option, okay, you can do the problem solving or not. They're going to need to have higher level problem solving to solve these problems that are going to come their way that we can't even imagine right now. And so this is why I thought, let's look at it for younger children in particular. And if we look at it for younger children, if you can start them when they're young with a type of thinking so that the wires in their brains will be basically wired properly for adding on logic and reasoning when they get older, then why not? And it's fairly straightforward when they're younger. It's much harder once they get older. So
yeah, absolutely. But Kim, can you explain a little bit about when you say younger grades? Are you saying grade 1, 2? Are you talking about KG Montessori?
Okay, well, I'm talking right now, I'm going to talk today about grade 1, 2 level, okay? And some of these ideas could be done at the grade 3, 4 level, but and even some of them, if kids haven't been introduced to it till grade 5 or 6, it's still a really good idea to get them going with this. You can start a couple of these ideas even in KG if you really wanted to. But I would say this is more about a grade 1, 2, and making sure that their thinking is straight when they're young. They're really keen when they're young. They haven't learned that, oh, I can't do anything. They still believe in themselves, and they can believe that they can do a lot too.
Kim, I wanted to. Okay, so Homa wants to have links to the Spirit of Math website. So Homa, we'll just share them on StreamYard, and you can see it. So Kim, when it comes to younger kids like 4-year-olds, so I was trying to teach Sharan skip counting. I don't know if that comes under problem solving, but it's really, I feel, like some people believe that don't teach them anything except like just basic 1, 2, 3, 4, 5, like counting and spellings and just how to write them, because if you teach them too many concepts together, they get confused. Is that true? Like, should you not teach them backward counting till they've learned forward counting properly? Should you not teach them skip counting till they're 100% certain on backward, or is it okay to teach them everything?
You combine a whole bunch of things. Okay, so I don't know how you did that, but basically, when you're teaching a lot of different ideas, you do have to make sure that the basics are there. It doesn't have to be 100%. You can add on before the 100%, and sometimes adding on actually makes the other 100%. If you just stay with the other, like let's just count one by one for too long, you actually don't get that stretch. Once you start going into, oh, let's skip counting. Let's do the skip counting, 2, 4, 6, 8. Oh, which ones did you miss? Oh, cool. So now all of a sudden they have to know how to count by ones because they're actually applying something a little different and they're having to go back. And now it has more meaning, that counting up by ones. And oftentimes that meaning is left out. And that's why people have a problem. So if you're just teaching just to teach another idea, but you're not connecting it to something that they had before, then it's a problem. It's always going to be a problem because the kids are trying to remember this and they're trying to remember this, and there's no connection point. If you started with the counting up and then you introduce the skip counting, oh, you've combined, and you make sure that they can see that they're missing one every second one or every third one if you're going to skip count by 3s or 4s. So if they didn't have that one by one, they could just memorize the other, but to actually make meaning of it, you go back and you show them how it's skipped over. And that skipping over, now they know why it's even called skip counting. Okay, so that's why I just thought you have to be careful when you're talking about that, because it's not just about is it good or bad. It's bad whenever you don't connect ideas. Let's put it that way. Okay, but to introduce a lot to kids, if your child's able to do it, then do it. And if you introduce something and they sort of go, what? And then you link it, but don't push it too hard. Let them see it and then get them to sort of discover. And if they're discovering, oh, what if we skipped every second number? What numbers do you get? Oh, and get them to figure it out. Now it becomes much more meaningful. It becomes more interesting. And you don't just say, here's something else. You actually take from what you've got and you move up and you add on to it. And now they've got something much bigger. Okay.
Absolutely. Kim, we have another question about like something that we were actually discussing on Scary Ammi today, which is learning objectives for children, and how we were basically talking about how sometimes the idea of private tutoring in Pakistan can be really frustrating, because while schools have now in Pakistan at least have extensive systems of training for teachers, the private tutors obviously don't go through, like they're not part of a big organization, so they don't have, a check and balance and like somebody supervising them and then training. So that can be a problem. So hence, when the mother is teaching a child, and if she's also not trained, what is the better way to teach? Like, for example, Kian and I were doing the Spirit of Math Venn diagrams. So is a better way to teach to first completely finish Venn diagrams on day one and day two you do a different topic? Or is it better to pick up at least two, three topics and then play with them over 3 days? Like,
Okay.
is it
Yeah, good question. I understand what you're saying. What we have found, and this is why we created our curriculum the way we did, is for the younger children. We introduce one type of question, like it could be Venn diagrams, it could be what we call all but problems, and it could be some other types of problems. We know the types of problems, so we're able to say, let's just work on this. And our contest has been divided up into different types so that the children, when they're younger, they work on that, they consolidate it. They get an understanding, then you can do twists and turns, and then that improves their reasoning skill sets for that, and also, well, the reasoning thinking, sorry, and then also the skill sets, the math skill sets that are associated with that. But the reasoning then becomes clear, and it also becomes automatic, where they'll look for these certain things if you're focusing on the reasoning. The skill sets themselves will be developed too. And if you've got good skill sets and you've developed them properly, the reasoning actually sort of builds in, because it's not just to do it because you're supposed to do it this way. It's actually, why is it done this way? So with the younger children, we focus on one idea, like a Venn diagram or an all but, and we do several questions like that, make sure they're good, and then we go on to the next one. And so for the younger children, we found that that works very well. And then we combine a whole, like the ones that they've learned, and we give them, okay, now recognize. So if you've introduced 5 different types, then you will just put 5 on a piece of paper of all the different types. They have to recognize which one, and then they can solve it, because that recognition is also important. When we're talking about the older students, we actually work with different ideas. And this is that we actually, in grade 5 and 6, just introduce them to hundreds of problems at once, literally hundreds. And so when they've got that, they're now at a level where actually a big skill set is to be able to identify what kind of question it is. And then the actual skills themselves, the mathematical skills, are just part of it. But the harder thing is figuring out, what type of question is this? What's reasoning? What kind of thinking do I have to do? So that takes years to develop, and hundreds, literally hundreds, thousands of questions over the years. So, so when you're talking about what's better, it depends. Once they get to a certain age, you don't have time just to go this one and then this one and then this one. It's too late. Like you've just got to pull to those kids. Okay. So that's basically, I don't know if that's answered your question.
yeah,
But
yeah, no, it does. But when you say younger children and older children, like you explained 2 different strategies. So the younger ones are grade 1 and younger, and the older ones are grade 2 and above.
No, good question. Thank you. So what we have found from kindergarten to grade 4, we use that one method where it's just very specific. And the part of the reason is up to grade 4 is because we want to ensure that logic and that reasoning is getting in there. And so we're establishing that when they're younger. So when they get older, it's more about applying the mathematics, and the reasoning will come if they haven't learned it before. But it's sort of all at once, because they now have to go up a completely different level. Now, remember too, we are working with high performing students. And if we want to take them to the top, like to the global standard, we need to push them out like that. So this is why it's really critical. You talked about good tutors. Good tutors will understand that and will have access to that information, have that experience. And it's very, very difficult to find that. And this is why we even find one of our major, our critical points, and the hardest thing for us in our company is finding, first of all, finding good people. Secondly, people who know enough to be able to teach to this level, keeping that training going, and having a community of teachers who can talk amongst each other. Like, how do you do these questions? What's this? And so that it's really hard. And I think this is why, even with Spirit of Math, that it's been quite successful, is because we have the resources. And so they know, okay, these work, let's work with this. And then the teachers can go from there. But not to have those resources is very tough for a tutor. They very rarely have that many. And even for a parent doing it on their own, it's Yeah, and I mean this has taken us literally over 30 years to develop, and you don't have 30 years. And
Yeah.
you don't have, like, even when I look at the people involved, it's not just me who wrote this curriculum. The people involved, my father, my mother, all the other people in the education department, Fraser Simpson, who's a cryptic crossword person for New York Times. I mean, his thinking is in there. Some brilliant thinkers have all included their ideas with this type of
Yeah.
problem solving. And as a parent, you can't replicate that. So you do need to find something. And that's just, I'm not trying to sell Spirit of Man. I'm just saying find something, because it will help you. It will take you from here up to here immediately. And you
Yeah.
need that help. Okay, so that's bottom
So
line.
this is also like a discussion we were having, right? So I think you're absolutely right. Like as mothers, especially those of us who are not teachers, and even if you are teachers, we like I'm not a teacher. Like I wasn't trained in how to teach younger children. So that's why I think it's really so we've understood that in Pakistan you're not going to get like private tutoring in the US and Canada is really expensive for a reason that those teachers are highly trained and highly specialized. It's not that way in Pakistan. Generally, there is no like standard in tutoring because anybody can set up and say, well, I'm offering online tutoring, so I'm out there, and there's no way for a parent to really judge because this like it's just like that. So I want to ask you that what like are there any resources that you feel are reasonably priced, not just in maths but also in English and science, which can kind of act as a guideline for parents? So I personally feel that in maths, there are good resources like the Spirit of Math resource, the International Kangaroo website, I think Olympiad, like etc. Like I don't know why I haven't found good resources for English or science. So I was wondering if that's just because I'm looking in the wrong places, or what do you say?
Um, is it Fireworks Publishing or Fireworks something? Michael Clay Thompson, he does a very good for English for high performing students. That whole Fireworks Publishing is for gifted students. I think it's Fireworks. It's something like that. That's a good resource if you have high performing kids. And those resources are very good. I would recommend those above most out there. Otherwise, you're very likely to get the regular type of thing that you could just go to your bookstore. And I've been to the bookstores there in Lahore and Islamabad, and the bookstores there actually have a lot of good resources. It's all the same type of thinking, though. If you want to do a different type of thinking and go beyond that, I would highly recommend that. I would have to.
Oh, I found it. It's called the Royal Fireworks.
Yes, that's it. Yeah, thank you very much. Yes, and that I would look at, because there's a lot of very, very good ideas, and you're going to bring your kids up to a completely new level.
And is it very expensive or it's okay?
I would say it's not expensive considering everything. Okay. And the value, because sometimes you buy things and you think, oh, I've spent money, or you think, okay, it's worth a lot because I've spent a lot. But in fact, it probably wasn't, the quality of this material is excellent. That's what I have to say.
And what about any others? And what about science?
Don't they have a science in there now too? I thought I know that they have a couple of different subject areas. So I don't
only see.
I'll have to do some research and see if I can find some others. So I just know that that's a very good place. And if you want some help too, they're sort of associated with different people who are experts in their field, and experts for high performing or gifted children. So they go deeper, and that's why you get a different perspective. Okay. So I think I'm just wondering if we can go, okay, you got okay, good. Okay. So I'm wondering if we could possibly go to the problem solving, and then we can answer questions. I just want to make sure we don't run out of time.
Just one last question. So the debate for the last 2-3 months in Pakistan has been the single national curriculum, which is historic because Pakistan's never had that. And one of the issues is the emphasis in Urdu. So at this time, like right now, Urdu is the only thing taught in Urdu. And then, yeah, Lubna, I'll put all the resources in this. But they're saying that now religious studies will be taught in Urdu, social studies will be taught in Urdu. Basically, they're moving towards more of, the medium of instruction being Urdu. So they haven't said that maths will be taught in Urdu, but like the fear is that maybe eventually everything would be taught in Urdu. But the ones who are for this program say it doesn't matter what language something is taught in, as long as it's taught well. And on the other hand, those who are against it say, well, but English is the language of the world. So does it make sense that instead of furthering English improvement in Pakistan, we're saying treat English as a subject and learn everything in Urdu? So can you tell us, is there any like data that says it doesn't matter whether you're learning maths in English or Japanese or Chinese or Urdu, as long as you're learning it well, it doesn't matter? Is it a good idea to do localized learning?
Okay, so the debate is out. There's lots of people proving both sides. And I don't know. And I'm not going to
very fiery debate. Every day we do live sessions on it.
Okay, so I was actually in a debate there about this whole thing in Pakistan, actually, and Beacon House, and it was with Beacon House, and a whole big debate about this. And I was on one side, and other people were on the other side. So, my whole I think it's critical that you understand the concepts. There's been a lot of different trial and error here in Canada as well for that. For example, we have French immersion schools, and I know one school, very expensive private school, who that found that the kids they were trying to teach the mathematics in French, and they finally went back and said no. In fact, they bounced back and forth, but they actually, at one point, I don't know where they are now, at one point they said, we're not going to be teaching the mathematics in French, we're going to be teaching it in English. And for different reasons. One was the understanding, too, is because people speak in English and mathematics throughout the world, too. And if you're going to be speaking about these concepts and these ideas, we need to have that. Now, having that understanding, the basic concepts, there's a lot of advanced level concepts that are language-based in mathematics. And people don't think that. They think it's just all number-based. But the numbers are based on language-based ideas. And they're ideas that you cannot represent any other way except through numbers. So when you start with at young ages, it's very language-based, and then it transfers sort of gradually into it becomes number-based concepts. And that's why you get the transfer from the younger children with the idea, like teaching mathematics is very different than even high school, because you've transferred from the language-based conceptual understanding up into a number-based conceptual understanding. And this is why there's such a gap between high school and elementary school too, in terms of how to teach mathematics. So with that in mind, I think someone who's very smart about this will probably want to do a little bit of both. You teach some of the concepts in their native language, whatever that is, and then apply it to the English so that the kids can see both and understand the concepts in both languages. One of the main issues with learning a second language, and this is a thing I found when working with the kids in Pakistan, is they understood the words. They didn't understand how to put the words together to make a concept in English. So that was very different. Having vocabulary and using it within context and conceptual understanding, it was missing in English. So this is why somehow, if you're going to be doing this, if you're going to teach in Urdu, teach the concepts well. Make sure they are being taught with concepts in Urdu so that they understand, they can apply it and put meaning to it. Then when they're teaching the vocabulary of English for the mathematics, they can apply it to the concepts too. So you teach the concepts in English, the vocabulary, the concepts, so they can relate it to the vocabulary of the Urdu concepts, the same thing. Now, what happens, so, and this is what we found last year, is when we were actually translating some of our problems for our contest, in some languages, some of the concepts that we had could not be translated. And it was from people who were very good in English and very good in this other language. If it was Korean or some other language that it was, they just said, we don't even have this concept in this language. So for the kid, there may be some concepts that you can't describe in another language. And you need to understand that in English, so that when you are working globally and you have you're actually working globally, you can actually speak with the concepts that people are talking about in the English language. It's not just this word with this word. It's when you put the words together, you've got a whole new meaning. And that's what I think people are missing when they say it's either in English or in Urdu. It is more about, can you say this in Urdu, these ideas? Or can you just say them in English? And how do you teach these ideas in English, and the ideas in Urdu? So it's more of the evolution, I think, of ideas. And sorry, I went off a little bit there. Maybe I went a bit too deep. I'm not too sure. But I think if there's someone really smart out there working with this curriculum, that they are looking at how to transfer the ideas over to English. And so that those kids, yes, the future is English. It is already here. And kids have to be able to think and work in English too, with the ideas, not just with vocab.
Okay, great. Well, maybe we can do like a separate session on the single national curriculum, because it's also, the curriculum is so thick and so detailed that not all parents have actually gone through it in detail. So a lot of us are just kind of picking and choosing and getting worried. But Lubna is saying that, yes, let's have Kim do one on just the curriculum. Especially if you could take a look at the maths curriculum that's out there. Is it good? Is it bad? Is it ordinary? Should we fear our children's futures are down the drain, or should we be happy that the government's come out with an amazing one? But let's move on to problem solving. I think you had a PowerPoint to share.
Yep. Okay. So I'm going to just get this going here. Okay. All right. So what I wanted to talk about, as I said, maths problem solving for younger children. Where do you start? And I wanted to first of all explain what rich problem solving is, as opposed to just the everyday, some things that you might see. When I say rich, it means it goes deep, it has a great impact. So if you're spending a short period of time, it will have a greater impact than just giving them something a long period of time with not too rich problem solving. You're not going to actually get as far ahead of the kids. So that's what I mean by rich. So first of all, it needs to have an application of the mathematics. The actual mathematics itself should not necessarily be the focus of the problem until the kids get older. Remember, this is younger children. So the application of the thinking, and then you just use a little bit of the math. So the procedures and math facts are used as part of the question, but not the focus. It is only required to get to the end point. So get into the question. You want to have a rich problem where it's a little tough just to even think about what is it that they're asking, how do I think about this, and so on. So higher level mathematics skills, I've already said this, not necessarily required. And also with a rich problem solving type of question, the answer is not obvious. In fact, sometimes the obvious answer has been put in there, like what you would think would be the obvious answer is a red herring. It sort of leads you off to the wrong thinking. And so oftentimes what we'll do is we'll give kids a question where they think, oh yeah, I can do this really fast. And then they find out, oh, it was wrong. Well, what do you mean it was wrong? And then they have to go back and rethink about it. And that's a good rich problem, because then you know, okay, they went to their quick thinking, but now they know to back up, think a little deeper, and then off you go. And we do this for the kids because it helps them when they get to the next question. They'll go, oh, this looks easy. And they go, wait a minute, no. this is spirit of math probably isn't that easy. So then they stop and they start thinking. And that's really why you want an answer that's not necessarily obvious. And then thinking and reasoning is required to answer it. It's not just a memorization of this is how you do this. So that brings me to the last point, which is discussion is often required. And if you have a question where discussion evolves out of the problem, then you know, okay, we've got a Goodrich problem. And then there's debate that ensues and so on. And so that's really what you want. Okay, so the next thing is I thought I'd just say what rich math problem solving is not. Putting words into a maths operation question. So for example, and this is a big thing with me, is when people say this is a math problem, I think, well, it's actually not a rich problem. You call it a math problem, but this is not what I'm talking about. So Irfan bought 3 bags of apples, and each bag had 4 apples. How many apples in total did he buy? And this really is more of an operations-based question, and it doesn't really involve a lot of logic or reasoning. It involves some basic reasoning, but hopefully can go beyond this very, very quickly. So that basically the answer is 3 times 4. So you can see it's transferring from language to numbers. That's the skill that the kids have to get with this type of question. And like I said, the very basic reasoning, the reasoning is more of a multiplication or addition reasoning. So that, I would say, is a basic level, very basic, and you want to go beyond this very quickly, okay? So let's look at an example of something that is not even using math numbers. There are 2 arrows below. One of them is not pointing up. What arrow is the other one? And so this actually gets kids to start reasoning when they are young. And when this is critical for mathematical reasoning as they grow older. And if you're just focusing on questions with numbers, you're going to miss this very critical type of thinking that is required in order to move forward with mathematics. So here's 2 arrows. One of them is not pointing up. So basically that means it's pointing down. Okay, that's this first part. One of them is not pointing up, so it's pointing down. What arrow is the other one? Well, it's the one pointing up. Okay, so I've put this in here, and I know I've talked about this in the past. I just cannot emphasize this strongly enough. Because if you don't even have this, you're going to have kids who are going to struggle with problem solving the rest of their lives if they don't have this basic reasoning. Okay, here's another one. And this one basically is a subtraction is the mathematics and the procedures that you need to use. But the thinking in here is different. Like you require deeper thinking. So 14 little Siamese cats lay snoozing in the sun. All but 13 ran back home, leaving only, how many? And so you want to put in 1 in here because it rhymes with sun, but is that the answer? So then the kids have to look at this, and the actual mathematics is not difficult, but the reasoning is. So let's look at this reasoning. All but 13 ran back home. So you can basically say all ran back home, but 13 didn't, which means that 13 cats stayed. So leaving only 13 would be that last line, okay? So
leaving only 1, right?
No, 13 all ran back.
13 ran back home.
All ran back home.
Oh, so 1 ran back home.
Yeah. Okay, so if you get kids learning very young age to think through this, to think deeply. And I know we've talked in the past too about thinking deeply and not just running to the answer. If you can get them to stop and to have that confidence to stop and think about it And that does take confidence. So you're teaching kids actually confidence to stop and to question themselves and to question the question. Because kids who don't have the confidence will want to just get to the answer. And it's the same with parents who don't necessarily have the confidence to do this type of thing. They'll just be saying, just tell me how to do it. As opposed to, let's think, let's have confidence in ourselves that we can think through this. So even math problem solving requires a lot of confidence and a belief in yourself. So see this type of thinking, the mathematics itself, very easy. So this is why this question came right out of our grade 2 curriculum, because the thinking isn't. The thinking is tough, but the math isn't. Okay. So when you give a variety of questions, so this is, again, came right out of our grade 2, an assignment that we give to kids in about January. But this is only 4 of the, I don't know if there's 30 questions in here or something, but there's a whole variety. And kids, once they've learned, and like I talked about, you teach the reasoning for different types of questions, and then you give them a whole variety at once so that they can start to recognize, oh, it's this type, and I'm thinking about this, and I know that kind. And then you give them something they haven't seen before. And because they've got the confidence to answer the other ones, then hopefully they'll learn that confidence on how to get into a question. And later on in our grade 7 course, actually, we get really tough how to get into the question, what questions to ask before you can get in, just so that they can develop that skill set, which you can only develop by going through the experience. So, but for the younger children, make sure they've got exposure to lots of different things after they've learned the foundations. Then they start to build the confidence in even more. And once they've got the reasoning, then it's just the mathematics to get to the end. So I'm going to give you this question just to finish off with. This is a very short PowerPoint, but it's hopefully just to give you the basics and the ideas. And this question we give in grade 2, and then we give again in grade 5. And it's a brilliant one. I love giving it to adults too, because it really gets okay. And it sort of makes you go, ah. So I'll read it out to you. Bert has a bucket filled with blue sand, and Ernie has a red bucket. Sorry, Bert has a blue bucket filled with blue sand, and Ernie has a red bucket filled with red sand. Both buckets are the same size. Bert gave Ernie a scoop of his blue sand, and Ernie mixed it up with his red sand. Ernie then gave Bert the exact same size scoop of his mix of red sand and blue sand. Is there more red sand in Bert's blue bucket or more blue sand in Ernie's red bucket? Now, there's a lot of words here, and that's the first
more blue.
So
right?
So basically, what you have to do, first of all, the kids have to figure out, what's this saying? And so then you go through that. Well, what's the story here? And the story is, you've got 2 buckets. You take a scoop of the red sand out of the red bucket. You put it into the blue bucket. You mix it up. And then you take a scoop of that mixed up sand from the blue bucket, and it's the same size scoop. So the same amount of sand is going to go back to that red bucket of sand, and you mix that up. So you want to know now, do you have more red sand in this blue bucket, or do you have more blue sand in this red bucket? And the kids have to think this through. And so you go through a lot of thinking with the kids, and you can see how, well, you're going to have to talk about this, and this forces that discussion. And it's not necessarily that you've got that you just have to use the math and figure out, well, it's this. So I don't know if you've got an answer. Do you have an answer?
I think there is more blue sand in the red bucket. Am I right?
No, you're not actually, but that's a good. Thank you for answering. And these are not just brain teasers. These, like, when you're looking at brain teasers, it's not just like, well, actually, brain teasers get you to think, but This is the foundation to mathematics. And a lot of people aren't realizing that. They're thinking that math is just the procedures and using numbers. And this is why I'm emphasizing this. And I've heard people even say, well, this is like little riddles. And
somebody here is saying, well, this is a brain teaser.
Yeah. And it's like that. So use it. And if you can integrate this into the mathematics curriculum, now you've got the proper thinking and you're fixing the thinking. So when they're getting to the numbers, they're going to start thinking about it. So really what I'm going to do, the answer is there's the same amount of red sand in the blue bucket as there is blue sand in the red bucket. And you have
but
to.
This wasn't an option. The option was, is there more red in the blue or more blue in the red?
Well, then you have to think outside the box a little bit. You're right. Okay. And there is an explanation. We explain it to the kids. And that's another, if you want me to explain it.
Yes, please explain it. Sana is saying more red. Lubna is saying more blue. I is saying more blue. So I think all the moms have gotten it wrong. So I really understand how.
Okay, and it takes a while even for our teachers to sort of okay, this is how it works. Okay, so basically, when you've got the red bucket and the blue bucket, okay? And we've got equal size buckets, okay? So we've got equal number 3, 6, 7, 8 grains of sand in each, okay? So you take the 3 grains, and I'm using numbers here so that you can see why it works. Okay, it's not just, approximate. We are actually going right down to the grains. So we take the 3 grains of the blue, we put it into the red and mix it up. Okay, so we've got that mixed. Now, what you do then is you take back the same amount. So this is the key. You're taking back exactly 3 grains back into here. So if you took 3 grains of just red, then you're not taking back any of the blue ones that you left, any of the 3 blue ones that you left. You're just taking, if you took all red, then you would have all 3 red back in here. So you would have an equal number of red as you do blue here. So red in the blue bucket as you do blue in the red bucket. Does that part make sense at least? If you just, I'm going to get to this one soon, okay? So that's because you left behind all 3 of the blue grain or blue scoops grains, all 3 of the blue greens, okay? You left behind all that. And you could only have 3, which means that you left behind 3. So if instead you only left behind 1 and you brought back 2 of the blue, so you brought back 2 of the blue, that means you left behind 1, and that has to be replaced with the 1 red. So whatever you're replacing with has to come back here. So if you replace with 1 red, well, you still have 1 blue left, and 1 red came back over here because you replaced it.
Oh, okay. So both of them have 1 extra grain.
Yeah, because you're basically either leaving them all behind or you're bringing them all back, or you are whatever you left there has to be replaced with the red. So that replacement will equal whatever you left behind. Okay.
Wow.
Pretty crazy. So you can go back and you can have fun with this one yourself. Okay.
So would you say, is it a fair justification? It's Meerab's question that, Kangaroo also gives such questions, and these are just brain teasers driving our kids crazy. Is that a fair justification?
No.
And why is it important to understand all this?
Because when you're if you're just thinking of problem solving as like that first example that I gave you, all it is applying, doing a multiplication, then you're missing out a huge amount of mathematics and the mathematical thinking. So kids have to start developing the reasoning behind this and be able to justify it. This is actually justifying it with mathematics, with numbers. And so this itself, if you've got this justification and able to apply it and allow the numbers to get in here, then when you are actually looking at other things such as algebra, why is it that when you bring it over to the other side? Well, you have to keep that equality. And that is a basic concept of mathematics. And if you don't have this basic concept and this basic ability to think through things like this, you're going to have huge issues with the numbers later on, and you're just going to go and memorize. So this type of thinking is what is critical to really getting the thinking for the mathematics later on, and then the ability to use the mathematics within other ideas like this. So why not introduce this to kids when they're young? Why not get them to logically think through this? And it's not just, did I get the answer? That's not the point of this. Like the answer, hopefully you got it by thinking through it properly and not just, oh, that's what it is. Because if it's just, that's what it is, then you actually haven't developed the reasoning. And if you haven't developed the reasoning, that's a bigger issue. So it's not just it's a fun little thing to do. It is fun. And that's why we actually do it. We do it as well. I mean, we could teach this reasoning in a real boring way, but this is kind of cool. So why not? And why not give the kids some fun? It's kind of, well, it's fun. And what's life about? It can't be just all serious all the time. Okay. Especially in math, kids have to see that there's something more to mathematics and not just the numbers. Okay. So that's it for this. And that was all I really had for this PowerPoint. I just wanted to get to the ideas very quickly with you, and so I hope that helped.
Yes, that helps a lot. So we have quite a few questions. Let me pick up a few questions to ask. Okay, so Sana Asim has a comment on when we were talking about language and maths. She's saying, my father was schooled in a TART school. These are schools that don't even have furniture, and read tables of even 1.5 and 2.5. When he applied for the state bank, all the paper was in English. He didn't know what was the meaning of product in maths, but since he was MA English from government college, he figured out and solved the mathematical problems. His entire maths was in Urdu, but his concepts were crystal clear.
Yeah. Okay. So there's an example of just a concept of, like, if he understood it in Urdu, he could have learned it in English because he had the background in the English. He was able to apply it. And that's, thank you very much for that comment, because that's really, if you're going to think about doing English, maths in English, then ensure that those concepts are understood and adjusted properly. That's all I say. And I think it is important that when kids have that opportunity, especially if you're thinking of getting your children have the ability to go up to a much higher level than the foundational level, you're going to need to go there. If you want the foundational level for your child, and that's going to be enough for your child, do you really need to learn the English? That's another question. I'm not too sure. It may give them an advantage to know the English, so that when they are negotiating, when they're talking about things, you don't want anybody to take advantage of them. It might help. And for me, that would be important. I would want my child to have that advantage to not be taken advantage of. So I know that I was just reading this one comment that need to learn practical mathematics that they can actually use in real life. This is Tabia Alikan. And so when we say this, practical mathematics is important, and so is understanding how numbers and the mathematics actually works, so that they can actually make it practical. And sometimes the practical is there, but because they knew of how numbers work, they were able to actually solve a practical problem they've never seen before, because they understood how numbers worked. And if you have someone who doesn't understand the practicalities, for example, even understand, let's say percentages, and they won't even recognize that that practical thing was a percentage. But if they understood percentages and how to use the numbers really well, they would actually recognize, oh, there's a percentage, and now I can apply that to this practical. So you need to have an understanding of both. Okay.
Okay, we have an interesting question. Is it too late to start with kids who are older? And also, like, she hasn't mentioned how old, but can you also explain when working with older kids, like, where do you start with?
Okay, so I'm not too sure what older is. I would say we found that working with kids up to grade 7 really works. You can do a lot with kids up to grade 7. After that, it's almost like there's too much mathematics after that in terms of going to a much higher level. But grade 7 is a great year too. So I don't know what older was, above 10 years of age. That's fine. Grade 10, or age 10 is fine. You can do a lot with them still. Okay.
And is the way to teach children such concepts, is it like just practice, or like what is the way to teach children?
So the problem solving concepts is basically what I was showing is find the good, rich problem solving. So out of contests and so on, and get them to see how to solve those types of problems over and over again. So the reasoning becomes good. And then once the reasoning becomes good because they're doing the same type of problem over and over again, then they'll apply that reasoning to new questions. And that's really what you want, is the ability to apply the reasoning to other things. I often say to our teachers, yeah, it's fine, they can do that question, but did you actually teach it so that they've got the reasoning that can be used later for other questions? And if you didn't teach for the reasoning, then really, what have you given the child? You haven't really given them sustenance for the future. And that's really, even if you don't have all the different types of problem solving, at least take some and get some of that reasoning done, and just and figure it out with your kids. You may not even know the reasoning. That's okay. All right. And it's okay for your kids to know you're not perfect. I think that's, I was on another podcast this week, and one of the things that was focused on is really, how do we, one of the big things we were talking about homeschooling and online schooling, and one of the things I said kids can take away and that they need to learn is that parents aren't perfect too, and that's okay, and that they're not perfect. So remember that, please, all of you, and that you can be there and learning with the kids, and that's good for them to know. It's fine, and that you're confident learning with them, because then they'll learn that they don't need to be perfect when they're adults, and they don't have to know everything. And that's the reality of the world these days. You will not know everything. We know less and less. We know a lot more, but it's less and less compared to how much the globe understands.
Yeah, absolutely. Okay, so I think we have time for a couple more questions. So let's go through those questions. So Kim, since the Spirit of Math contest is coming up, any tips on how to prepare our children well? Like, should they be studying daily? Should they, like, any tips?
Okay, daily is yes. Make it so it's a normal part of their thinking. And if they can make it a normal part of their thinking, when they get to that contest, it will be a lot easier because, okay, I've got that reasoning. They immediately enter into it. This is why we give hundreds of problems a year to our kids, because it becomes a norm. That new level of thinking isn't all of a sudden they're going into it going, what do I do with this? Okay, so it's a very short period of time to the contest. So every day, a couple of, just do focus in, get something done, but don't just bombard them. I often say that when people, it doesn't matter if you're kids or adults, it's you can't drink from a fire hose. That's very difficult. So give them one ping pong at a time. Don't just throw a handful of ping pong balls. Give them one at a time and then grab it and then they can use it. Okay. So don't think you have to do everything all at once and then you panic. Just get them to focus in. I know we did this purposefully on our website here, as you can see, Spirit of Math contest, even free. There's some real, just some ones that we picked out. Even if you can focus on those, understand how to do those, then at least when the kids enter into the contest, they will recognize those kinds of questions if they're on the contest, which usually there's one or two or of those concepts on the contest, and then they'll be able to answer the question.
Okay, makes sense. Okay, we have an interesting question from Sana Nasir on how do you cope with tantrums while children are studying, especially like younger children when, after like 10 minutes, they're like, and I don't know if I'm the only one who feels like this, but I feel online learning has really affected their attention spans because, it's easier for them. It was easier for them to focus when they were in a classroom. But I've seen this with all my kids that their attention spans are not what they used to be. I think the laptop is so distracting. Is that true? Is that like a global thing that their attention span, like, when they were studying on a book, like at least that was all in front of them. When it's the laptop, you can open up YouTube, you can play a game. Like, I don't know if I'm the only one facing this.
Well, I don't know what the actual research is for that. I know what we've been observing is very similar. And we've got parents saying we've got a serious issue. Our kids just can't focus much anymore. And I think, I'm looking even at adults and they're having a harder time focusing for long. I'm noticing when I'm talking to them, they're going off, they're doing something else. And that wasn't like that when we first started this whole COVID online stuff. People were focusing better. They weren't disengaged quickly. And but now I'm seeing that they're sort of over there and then they come back and, oh yeah. I think personally, and I don't know, there's not research behind this, but when I'm watching this, what I'm noticing even with myself is when you're focused online, you have to be so focused on that. That's not normal because usually what happens in a regular system is that you've got something going on over there or over here, and you have these micro breaks for your brain. And I'm going to call them real micro breaks. And the micro breaks, like if a child was in school, they see someone doing something. Oh, okay, I see them, and they come back and they focus. And I think even for us adults, there's something else going over there, we come back and we focus. We're used to that, but that just gave our brain a micro break. And when you've got that micro break, it gives your brain a chance to sort out things and then keep going. So if we're too focused and the kids are too focused, yeah, they're going to act out somehow. And this tantrum while studying could be that. So make sure you've got enough little micro breaks. You've got little things happening that, or if it's not micro break, because that's really hard to do when they're online. What you can do is online, if you are a teacher, provide them with opportunity to have something going on with the kids so that they have the discussion time. You stop with the studies and you get the discussion going between the kids. You get some sort of fun. And they say, okay, now come back and let's focus for this amount of time. But it's very different than in a class, and you cannot treat it the same. And that's basically what at least I've been seeing. And for you at home, if you want the kids to focus in on something and then stop it after a while, do a micro break or a set break. So if you have children doing tantrums while studying, just find out how much time can they take. And before they have that tantrum, they get to that point where they're so frustrated, like a couple minutes before that, say, okay, break time. And then that way they can calm down, they can do a little bit of break, and then back they come. You're going to have to determine as a parent how long that is that they can focus. And if you want them to extend that focus, then extend it. But if you're finding that it's coming to like practically nothing, you've got a bigger problem. And I would say this is a big problem. I don't know the solution right now. I can think of some different things to maybe try, but it is a big problem. And if this is where our world is going to, then I would say, yeah, that you've got a bigger problem. So I just saw what someone said. I asked my girl a question. She said immediately both had the same amount. Cool. Way to go. And for some kids, it's like, of course. And they will explain it to you and say, this is why. And we overcomplicate it, but that's great reasoning. Good for her. Okay. So I think these are all really good questions. I hope this has helped you.
Yeah, absolutely.
Yeah.
Absolutely. So, Kim, I think a lot of parents are signing up for the exam. So maybe next week you could help us. I don't know if that's going to be too late, but like kind of help us figure out, how do you prepare your kid well for an exam like this? Because I think that in itself is a technique. Like a lot of parents, like I know I'm good at teaching them, but I'm not sure if I'm great at like teaching them how to take an exam and how to practice for it. Like that itself is a skill.
Yeah, it is. It is. Sure, we can talk about that next week, and I can talk about some little hints little tips to help you out. So that'd be great. Okay. Well, thank you very much.
Thank you so much. This was great. I still can't believe I got that question wrong, but great.
I'm glad you did. Sorry.
Look at the explanation again.
You'll have to go back and you'll have to think it through. Yeah, good for you. Okay, take care, everybody, and have a great week.
Thank you. Bye-bye.
Bye.